चलो स्टूडेंट्स, मैं क्वेश्चन ले रहा हूँ जो कि इक्विलिब्रियम में क्वेश्चन है। ट्रांसलेशनल एंड रोटेशनल इक्विलिब्रियम में क्वेश्चन है ये। क्वेश्चन ये है कि एक यूनिफॉर्म थीन स्फेरिकल सेल इज केप्ट एट रेस्ट इन यूनिफॉर्म इन इक्विलिब्रियम on an inclined plane of angle of inclination is given 30 degree as shown in figure. If the surface of the inclined plane is sufficiently rough to prevent sliding, then the angle alpha made by the plane of the hemisphere with inclined plane is. So if this hemisphere is in equilibrium, you have to find the angle formed by the plane of the hemisphere, this plane with the inclined plane. This angle we have to find alpha. So how you will do this question? This question is basically based on both translational equilibrium and rotational equilibrium. You have to understand the things. You have to understand even the condition of toppling. All these things will be you have to understand to solve this question. चलिए करते हैं। तो पहली बात जो हमें इस क्वेश्चन को सॉल्व करने के लिए रिक्वायर्ड होगा वो है फ्री बॉडी डायग्राम। थोड़ा सा मैं मैग्नीफाइड डायग्राम बना लेता हूँ so दैट कि मुझे एफबीडी समझना थोड़ा आसान हो जाएगा। This angle is theta and let me draw the hemisphere. So well, something like this. Not very good diagram, I guess. Let me. Well, so something like that. Well, all right. So this is what the hemisphere and this is the point of contact you can see. And let me write few things. This is the center of curvature of hemisphere. This point is the, this line is passing through the CG. So this point is center of gravity. And for hemisphere, this distance is r by 2. All right. And let me draw a point which is this point is P, say, and this is the point of contact of hemisphere and the surface. All right. So the normal reaction will be from this point P, and we know that the normal reaction is always perpendicular to the surface, and it is passes through the center of curvature of the hemisphere or sphere. So let me draw the normal reaction, which is like this, right? And then second thing I would like to tell you about the weight mg. Mg will pass through the CG and it must pass through the point of contact. Otherwise, what will happen? If it is not passing through point of contact, then there is a torque of mg about point of contact. So it will turn. It will not be in equilibrium then. So mg should pass through this point P, that is the point of contact. So let me draw this also. Well, so this is M. And let me take one moment and let me take this. This point is P. So first let me dissolve, this point P. This point is P. Okay. Well, All right. So what are the other forces acting on it? Apart from that, the forces will be the friction. So this friction will be this one. Why the friction? This is a static friction. Let me resolve the component of mg. One is mg sine theta and this will be mg cos. All right. So mg sine theta is downward, so the friction will be upside, static friction, and then mg cos theta, which is along perpendicular to the inclined plane. So now, so these are the forces acting on this hemisphere. One is normal reaction, other is static friction, and then mg. All right. So let us see the condition for equilibrium. Let's apply. So that will be for translational equilibrium. We can say the net force must be zero, right? So we can write net force must be zero, and then we can say along the plane mg sine theta minus fs is equal to zero, and we can come to know that fs is equal to f. All right. And second thing is what? Second thing is if you apply this net force in perpendicular direction, this is a parallel, and if I apply in perpendicular direction, summation f is equal to 0 perpendicular to the plane, then I will get n minus mg cos theta is equal to 0 and n is equal to mg. Now, let us see the condition for torque. And for that, and this angle is given alpha. So let me draw this angle alpha, which is the angle between this plane and the inclined plane. So let me draw the inclined plane. So this angle is given alpha. You have to find. All right. So let's say this angle this is normal. So this is 90 degree, right? This is 90 degree. If this is 90, then this and this is parallel. So this is again 90. If this is 90, this is 90 minus alpha. This is alpha. So let me write this is clearly this to be alpha. Right? This angle is alpha. Now for equilibrium, rotational equilibrium, क्या लिखोगे? Rotational equilibrium. So rotational equilibrium, because we have to relate alpha, I am not taking rotational equilibrium about point of contact because all the forces passing through that point and then there is no torque. Then torque is zero, right? And that is true for rotational equilibrium or equilibrium. But then we will not relate, could not able to relate alpha. So for that, I am taking the net torque to be zero about center of gravity. And then you can see there are three forces N, Fs and Mg. Mg is passing through Cg, then there is no torque of Mg. Then the torque will be due to normal reaction and due to friction. And torque of normal reaction about Cg will be clockwise and torque of friction about Cg will be anti-clockwise. And these two torque must be equal and opposite, then only the net torque will be zero. So I am writing it for net torque to be zero. We can say the torque of normal reaction about Cg must be equal to the torque of friction about Cg. Alright, so this torque is clockwise and this is anti-clockwise, so this must be equal, right? And opposite, basically net torque is zero, so we can say the torque of N plus torque of one moment, torque of N plus torque of friction should be equal to 0. And if I write in torque clockwise, if I take plus, then torque of normal minus torque of friction is equal to 0, and this is what I have written, torque of normal is equal to torque of. That's right. So I know that you got this thing. So what is the torque of normal force? Then I can say the normal force multiplied with the perpendicular distance from CG. So perpendicular distance is this one, right? So let me name this something. Let me name this point to be, say, I'm saying this to be some point here, and I named it to Q. All right. So what I'm telling you that this is what perpendicular distance, right? CG to Q. Then I can say N into the distance, that is CGQ is the perpendicular distance. Must be equal to what? The torque of friction, that is friction into perpendicular distance. Now the perpendicular distance, this is a friction. This is the R vector from center of gravity. Its perpendicular component will be this. And what will be this value? You know, this value we got it. This value is this QCG is what? R by 2. This angle is alpha. So R, this is R by 2. That is the center of gravity or center of mass for hemisphere from the center of curvature, that we know. So this is R by 2. So this will be R by 2 sine alpha, and this will be R by 2 cos alpha. So we know we have to find for friction the perpendicular distance will be this one, and this will be what? Total is what? R. Any distance from here is R. So what will be this one? This is R by 2 cos alpha. So this will be R minus R by 2 cos alpha. So let me write QP first. QP. This is the perpendicular distance. So N is what? N we got mg cos theta. And this value we got what? From here, R by 2 sine alpha. CGQ is what? R by 2 sine alpha. And this is equal to F is what? Mg sine theta. And QP is what? R minus R by 2 cos alpha. That you can see from here, right? This is R by 2 cos alpha, just I told you. So from here we can cut this Mg, and then it will be also R is out, so it will be cos theta sine alpha upon 2 is equal to this. We can write sine theta 1 minus cos alpha by 2, right? So let it put the value of theta. Theta is given 30 degree. The inclination of the horizontal for the inclined plane is given 30 degree. So put this value. So this will be what? Cos 30 is root 3 by 2. 3 by 2 into 2 sine alpha. Sine 30 is 1 by 2, right? And then 1 minus cos alpha by 2. 1, 2 is out. And then you can write root 3 by 2 sine alpha plus 1 by 2 cos alpha is equal to 1. So root 3 by 2 you can write will be sine, you can write this to be sine 60, and on cos 30 you can write cos 30 degree plus sine alpha, and this you can write cos 60 cos alpha. Cos alpha by 2, this is sine alpha, right? Let me check once. Cos theta, this is R by 2, so this is fine. So root 3 by 2 sine alpha plus cos alpha by 2. So we have written cos 30 sine alpha plus cos alpha sine 30. So let me write this to be sine 30, right? Because this is a little mathematics we have to apply. So sine 30 degree cos alpha, or you can apply even a different way, right? One moment, where this problem is also. This is what? Cos alpha. Cos alpha. This is 1. So sine 30 sine alpha, cos 30 sine alpha plus sine 30 cos alpha is sine alpha plus 30, right? Sine alpha plus 30 degree, and one I can write sine 90 degree. So alpha plus 30 is 90 degree, and we got alpha is 6. So this is we got it that the angle formed by the plane of the hemisphere with the plane of incline will be 60 degrees. This angle will be 60. So I hope you got this question, और आपको कुछ डाउट हो you can discuss to me. Thank you for watching, students.